cutting thousands of trees with a chainsaw would take weeks. That's why foresters built a machine that doesn't just cut trees, it eats them. And it doesn't really cut the tree down, it makes the tree disappear. Trunk, branches, brush. Everything goes through the same spinning head and comes out as thousands of pieces scattered across the ground. This is a forestry mulcher, and some purpose-built machines push close to 500 horsepower. But horsepower alone isn't what allows them to do this. The real violence is happening right here. At the front of the machine is a massive steel rotor covered with individual cutting teeth. Instead of making one clean slice through the trunk like a chainsaw, the rotor repeatedly strikes the wood as it spins. One tooth hits, then another, then another. The machine keeps feeding itself into the tree until solid wood becomes chips and shredded fiber. And some forestry mulchers are rated for trees approaching 20 inches in diameter. That's not a branch. That's a serious tree. But there's a problem. A forest isn't made entirely of wood. Under all that vegetation are rocks, dirt, buried stumps, and things the operator may never see before the rotor finds them. And when a machine this powerful hits something that doesn't want to be shredded, something has to take the punishment. That's one reason those teeth are individual replaceable components. They are the part deliberately sent into one of the most hostile environments you could give a cutting tool. Eventually they wear out. Sometimes they break. You replace them and send the machine back in. Which raises a more interesting question. Why would anyone need to erase trees this quickly in the first place? Because cutting the tree is often only the beginning of the job. With conventional clearing, vegetation may have to be cut, collected, moved, loaded, and hauled away. Stumps and brush create another problem after the larger trees are gone. A forestry mulcher changes the process. The machine moves through the vegetation while shredding much of it where it stands. Instead of producing a giant pile that has to be transported somewhere else, it leaves a layer of shredded material behind. That's useful when clearing overgrown land, opening rights of way for utilities and roads, maintaining vegetation, or creating fuel breaks intended to reduce continuous vegetation that can carry fire. But then engineers ran into another problem. What happens when the forest is somewhere the machine shouldn't be? A steep hillside can be dangerous for a conventional piece of heavy equipment. Dense vegetation can hide obstacles, and forestry mulching puts an operator remarkably close to flying debris and falling material. So the machines got stranger. Some mulching heads are mounted on excavators, giving them reach into slopes and places a conventional mulcher can't simply drive through. Others are mounted on dedicated tracked carriers built specifically for difficult terrain. And some forestry mulchers can even be operated remotely, allowing the operator to stand away from the machine while it works through hazardous areas. But at the extreme end are machines like FAE's PT-475. It's a purpose-built tracked forestry vehicle producing roughly 475 horsepower. And that's when the scale of this machine starts to make sense. A chainsaw is designed to bring a tree down. A forestry mulcher is designed to deal with what comes after. That remaining stump can stop construction, damage landscaping, and get in the way of future projects. Pulling it out sounds simple, until you realize what's hiding underground. So why don't workers simply pull it out and call the job finished? At first that seems like the obvious solution. Hook the stump to an excavator, pull as hard as possible, and let the roots come out with it. Sometimes that works with small trees, but mature trees are a completely different story. Their roots can spread several times farther than the trunk itself, anchoring the tree beneath sidewalks, driveways, underground pipes, and even building foundations. Pulling everything out often leaves behind a crater that creates far more work than the stump ever did. Instead of removing the entire root system, engineers realized they only needed to eliminate the part that gets in the way. That's where the stump grinder comes in. Unlike a chainsaw, it doesn't slice through the wood with a moving chain. At the front of the machine is a thick steel wheel, fitted with dozens of tungsten carbide teeth, one of the hardest materials used in construction equipment. As the wheel spins at high speed, it doesn't cut the stump in one pass. It shaves away tiny pieces of wood with every sweep turning a solid tree stump into thousands of small chips. The process looks surprisingly aggressive, but it's actually very controlled. Rather than driving straight down, the operator slowly swings the cutting wheel from side to side, removing thin layers one at a time. After each pass, the wheel drops slightly lower until the stump disappears several inches below the surface. That depth is important. Once the remaining wood sits below ground level, the hole can be filled with soil, covered with grass, or prepared for a new tree. From the surface, it looks as if the stump was never there. You might wonder why the machine doesn't keep grinding until every root is gone. The answer is simple: it doesn't need to. Most of the root system stays underground, where it naturally decomposes over the years. Digging it all out would require far more time, heavier equipment, and significant damage to the surrounding landscape, all to remove roots that are no longer causing any problems. That's why stump grinders have become the preferred solution everywhere from residential backyards to parks, golf courses, and utility projects. They finish the job without tearing up sidewalks, destroying lawns, or bringing in an excavator that might do more harm than good. But sometimes none of this has to happen. Sometimes they move the entire tree to a completely different location. Instead of bringing in chainsaws, they bring in one of the strangest machines ever built. A machine designed for one purpose: not to cut the tree, to move it entirely, roots and all. It's called a tree spade, and despite looking like a giant mechanical claw, it isn't grabbing the tree. It's digging around it. Each hydraulic blade slowly enters the ground from a different angle, carefully slicing through the soil. As they continue downward, the blades form a giant cone beneath the tree. Inside that cone, the roots stay protected. The surrounding soil stays intact, and the entire root system becomes one solid mass, known as the root ball. Once the blades meet underneath, they close together, locking the tree, its roots, and thousands of pounds of earth into one enormous package. Only then is the tree lifted from the ground. Still alive, still standing. The tree is loaded onto a truck, taken to its new location, and lowered into a hole prepared days in advance. Because moving the tree is actually the easy part. Keeping it alive is the challenge. And surprisingly, when everything is done correctly, more than 90% of transplanted trees survive. But this brings us back to the original question. Why go through all this? Why spend so much money when cutting the tree would take minutes? Because sometimes the tree is worth far more than removing it. Some have stood in the same place for over a century. Some are protected by law. Some define the identity of an entire neighborhood. Others increase nearby property values, provide habitat for wildlife, or create shade that would take generations to replace. Professional arborists even have methods to estimate the value of mature trees. And in some cases, that value reaches hundreds of thousands of dollars. Not because of the wood, but because of everything the tree has taken decades or centuries to become. Most machines exist to remove obstacles. This one removes the obstacle without removing the tree. Because replacing a machine takes money, replacing a 100-year-old tree takes another 100 years. And that's something money can't buy.